Hello everybody, this is the notes for September 28th. Today in class we did dividing polynomials. The learning target for today is I can divide polynomials by using long division, and this is coming off page 13 in your notes. Page 13 in your notes. Okay? We're going to do 3 examples. Starting with number 1. I'm going to write this here. I'm going to divide 6x cubed minus 25x squared plus 18x plus 9 divided by x minus 3. When you're dividing these polynomials, you want to make sure all powers are represented in your dividend. I have x cubed, x squared, x, no x. So that works out well. My divisor, I'm dividing by x minus 3. Okay? You want this first term to look just like this term. So what times x gives you 6x cubed? That is 6x squared. Because 6 times the understood 1 is 6. X squared times x is x cubed. 6x squared times negative 3. 6 times negative 3 is negative 18x squared. The reason I put 6x squared above the 25x squared is because they are like terms. You want to line your like terms up. Put a minus because in long division you subtract, but remember that minus changes all the signs. So that's going to make this a negative and this is a positive. You know you are doing it correctly when the first terms cancel out. I'm left with negative 28 plus a positive 18x squared. That gives me negative 7x squared. And I can combine those because those are like terms. Okay, I have one term down here. My divisor has 2 terms. I need 2 terms down here if my divisor has 2 terms. So that means I need to bring one down. Okay? You want this first term to look like this term. What times x gives you negative 7x squared? That's a minus 7x. Negative 7 times 1 is negative 7. X times x is x squared. Negative 7x times negative 3 is positive 21x. Put your minus. Remember that minus changes all the signs. Left with negative 3x. I have 2 terms over here. I need 2 terms down here, so I bring this down. I want this term to look like negative 3x, so I'm going to multiply that by negative 3. Put a minus. That minus changes all the signs, and you get a remainder of 0. So your answer is 6x squared minus 7x minus 3. Alright, the second one on page 13. Now let's look at this one. On your notes on page 13, page 13, you have 9x cubed minus x minus 3. Notice the x squared is not there. So when you write this problem, you have to put a 0x squared in there to account for that x squared power. What times 3x? You want this to match up to that 9x cubed. What times 3x gives you 9x cubed? I hope you say it's 3x squared because that's correct. So I'm going to put that above the x squared. Line your like terms up. 3x squared times 3x is 9x cubed. 3x squared times 2 is positive 6x squared. That minus changes all the signs. Okay. I have one term. Over here I have 2 terms. I'm going to bring one down. Minus x. Alright, now I want 3x to look like negative 6x squared. That's going to be minus. What times 3 gives you negative 6? A negative 2. What times x gives you x squared? That is x. So negative 2 times 3 is negative 6x squared. Negative 2x times 2 is negative 4x. Now, what does that minus do to everything? Changes the signs. The first term should cancel out. Negative x and 4x gives you 3x. I have two terms over here. I need two terms here if I can. I bring that down. Now I want 3x to look like 3x, where it already does. So I'm just going to multiply by a positive 1. 1 times 3x is 3x. 1 times 2 is 2. The minus changes all the signs, which cancels the first terms out. Negative 3 and negative 2 gives you negative 5. Now you have two things here. You need two things down here where there's nothing else to bring down. So you're at the end of the problem. That is your remainder. So you would write it as 3x squared minus 2x plus 1 minus 5 over. This is how you write the remainder. I put a minus because of negative 5 over the divisor. You can have it this way, or you could write it I would take it either way. Number 3. Checking my problem, all my powers are represented. 2x to the 4 minus 4x cubed plus 13x squared plus 3x minus 11 divided by x squared minus 2x plus 7. My divisor has three terms in it. You want this first one to look like 2x to the 4. What times this would give you 2? 2. What times x squared will give you x to the 4? 2x squared. So I go above my like term with x squared and put 2x squared. 2 times 1 is 2. X squared times x squared is x to the 4. 2x squared times the negative 2 is negative 4. X squared times x is x cubed. 2x squared times 7, that is positive 14x squared. The minus changes all the signs. The first one's cancel out, the second cancel out. I'm left with negative x squared. Okay, there's one term. There's three terms in my divisor. They have to match up. So that means I bring both of these terms down. Now I want x squared, this first term, to look like this. What do I multiply by x squared to get negative x squared? I'm hoping you're thinking negative 1. And I put the negative 1 above the negative 11 because those are like terms. They're constants. So negative 1 times, that's going to give me negative x squared, a positive 2x, and a negative 7. The minus changes all the signs. I'm left with x minus 4. I do not have another term to bring down, so therefore I do not get to have three terms on my divisor. That's how I know I'm done with the problem. So that's my remainder. So my answer would be 2x squared minus 1 plus x minus 4 over x squared minus 2x plus 7. That is how I write my remainder. So this is the answer I would be looking for. So those were our examples for today, Wednesday, September the 27th.